How we doing, physical science students? Mr. Tima here, going to talk to you about the next phase of our classification of matter notes. And we're going to talk about physical and chemical changes. If you've been looking at the big chart that was out there, and remember, our chart looked kind of like this. It had this big chart up here. Go back all the way through, but it was this big chart like this. Okay, on the back side of that chart, or on the next one, is another set of charts, but hopefully it's breaking it out for you. But here we go. We're going to start with physical versus chemical changes. We're going to start on the left-hand side. First of all, physical changes. Let me really point out that we got to understand that there's this thing that physical changes are something that we call that are reversible, okay, or can be undone, or shall we say, put back together, okay? It might not be easy. That's the hard part. Some people say, well, that's not easy to do, but it can still be done. So a physical change is a change in size, shape, and state, but not composition. Or composition is just a fancy word for what is it made up of, okay? So for example, if an ice cube melts, it turns into water. Well, it's still water, okay? Ice is water. Liquid water is water. If we allowed that water to change to steam, it still is water. And could we trap all that steam and let it condense back into water? Yeah, it wouldn't be easy, but you can change it back into liquid water, and then we could change it back to solid water, which we call ice. Chopping wood. Technically, yeah, when you cut a piece of wood, it's still wood. Could we put that log back together? It might not be easy, but you could puzzle piece it back together if you had to. Okay? A physical property is any characteristic of a material that you can observe without changing, that word of changing what it actually is, okay, of that substance. So for an example of physical properties are color, shape, size, texture, temperature, volume, hardness, and viscosity. And viscosity is just a fancy word for flow of liquids. If you have a really low viscosity, you flow really easy, like let's say water as an example. A high viscosity means it doesn't flow very well at all. And that would be like pancake syrup or something like that. All right. Remember that word color down there. Remember the word color down here. Okay. Notice like the physical property is that shirt you're wearing is green. This guy's blue jeans are blue. Okay. The hammer is brown, or excuse me, that's called an axe. Okay. The axe handle is brown. Okay. That's going to be very important in our next couple of slides here. Now, chemical change. A change of a substance into a different substance. Okay. Now, these 6 things tell you that it has gone through a chemical change. Now, it can be one of them, it can be 3 of them, it could be all of them. But if it does any one of these, it has gone through a chemical change. Gas is given off, which we usually see with bubbles. A color change. Now, remember, back in physical change, we said that, or a physical property or physical change is color. Well, his blue jeans are blue. But if I dump, let's say, bleach on them, what's going to happen to them? You're right. Those blue jeans are going to turn like a white, or it's going to get bleached out, if you will, right? And we say it loses its color. Well, now that's a color change. Those blue jeans are not the same that they were before. And can you ever, after you dump bleach on your clothes, get them back to the way they were? No. Okay. Exothermic, which is gives off heat. You might have heard of these terms before. Endothermic, which means absorbs heat. I always think of exothermic as the heat is exiting, and endothermic is the heat is entering. Gives off light. Think of something that gives off light. Something that maybe you light and it gives off light eventually. Fire's a good example. Fireworks, a flare, something like that. And if you use those things, like you light off a firework, you ain't getting it back. Okay? Sound given off. Boom, there's a loud explosion. And then finally, the word precipitate, which means a liquid is added to a liquid, but all of a sudden a solid forms. And you know this word precipitate. we say precipitation a lot in Ohio. And what's precipitation in Ohio? Usually two things we talk about: rain, and usually in the winter so we can get out of school, snow. That's right. And when we say we have a precipitate, okay, or precipitation, that's literally gases in the air or liquids coming together and falling out of the sky. Okay. A chemical property, obviously, I already talked about it. If any of these happen, 1 through 6, then you have gone through a chemical change. And as you might have heard me say, chemical changes are not reversible. You cannot send it back. Okay, you cannot send those back. So once we light off a firework, that's it. So here's some examples. Fireworks are a great example of a chemical change. Fire. You burn that wood. Yeah, it was wood. But after you burn wood, it's no longer really wood. We call it coals or ash or whatever you want to call it. But we don't call it wood anymore. Unlike when I chopped wood, it's still wood. I love an egg. When an egg, first of all, I do like eggs. But if I take an egg and I crack it, Humpty Dumpty, and I dump him in a pan, could I technically scoop up that egg and put it back in the shell and super glue it and spend hours of time putting them back together? Yeah, I could. That would be a physical change. But as soon as I put heat on it, what happens to an egg in the frying pan? It doesn't look like this when it first goes in. It's like clear. And all of a sudden, we start getting this white. And if you've ever left it in long enough, the yolk will turn like a darker orange or yellow. And that's because we now have a color change. And sometimes you can see bubbles because it's frying, and you can see those bubbles, and you can feel the heat giving off, and you hear the sizzle, and all these things that are all part of these things right here. Okay. Here's a great example of a precipitate. Okay. You have a liquid and a liquid. Look, they're both clear. You pour this sucker in, and look, all of a sudden, now it doesn't look like a solid piece of rock falling, but this is actually chunky stuff falling out. And there we go. And what else happens here? What else tells you this is a chemical change? If you said color change, you're right. If you said color change, look, clear, clear, now we have yellow all of a sudden. Okay. This is something that we're not really going to test you on this year, but I like to add this every year just so we can talk about it. And because it's very important in science that we know the two ways that we separate things, especially after they go through a change. Okay. The first one's probably the most familiar to you, and that is filtration. Okay, or filtering. Okay, the separations of solids and liquids. A great example that you probably have seen 1,000 times is a coffee maker. Okay, the Keurig. Okay, I put the pod in here. We run water through the pod. There's ground up coffee. We get liquid coffee and water in the cup, and up here are the grounds. Hopefully, you're not getting grounds in your coffee. Is there something else that you might think of that you filter? Filter. Maybe you buy filters for your house for this reason. A lot of people will always mention that they have furnace filters. Sure, it doesn't just have to be a liquid. It could be a gas, could be air moving through, okay, and filtering particles out. If you have allergies, they filters out the pollens and stuff. And then usually I always get another example of somebody saying, well, like I have a Brita filter, Mr. Team. I have that thing that's in my ice in my refrigerator that we pour water through, and then we get better tasting water. Maybe some of you have water filtration systems in your house, stuff like that, where you have to change the filter out. Here we talk about filter paper, but that's usually like a charcoal filter. So filtration. The other one, the more kind of less talked about at your age, but something if you want to get into science, is something called distillation. Distillation is just a fancy word for boiling. It is the separation of a liquid from a liquid, okay, or getting a solid that has been kind of dissolved in that liquid out. So, for example, some really fancy boats will have a reverse osmosis machine, but basically it's a distillation machine. So, imagine there was salt water here. Okay, we had salt water here, and we started boiling that salt water. Well, at 100 degrees Celsius, water is going to boil off. Okay, and all of a sudden it gets into this thing, which is a cooling tube or a condensation tube. And what happens is that water condenses. Okay, it condenses, and then we get pure H2O over here, or what they call the distillate. Okay. What would be left over here eventually, if you let this run and run and run, is that you'd see a bunch of salt down in here, and we'd have pure H2O over here. There'd be salt and some other stuff, other particles, but pure H2O over here and salt over here. Okay. This is actually, if you've ever watched the science channels and stuff, they talk about like making like rubbing alcohol or distilling alcohol. And what happens is you take that alcohol mixture, alcohol boils or vaporizes quicker than water. So at like 70 degrees, alcohol comes up here and condenses, and we get pure like rubbing alcohol over here, and left over here is the water or whatever it's made out of. Okay, so that's distillation, just a fancy word of boiling. Here's a quick example for you. Let's talk about this really quick. Okay, let's talk about this really quick. Oh my gosh, for some reason I have sand and sugar and wood shavings. What a heck of a combination. So here's the sand, here's the sugar, okay, and here's the wood shavings, okay? And here, we'll put this for SU for sugar, okay? How am I ever going to separate these? Now, the sugar and sand are about the same size, and we're going to assume the wood shavings are so small that we can't really pick them all out. So how are we going to do this? Well, the first thing we can do is we can add H2O. We can add water. If we add water, okay, if we add water, so we'll put a little water line up here, my red water. Okay, there's my water line. I'm trying to do this on the computer. I'm sorry. I'm not as good as Mr. Longbreak. Okay, but if I add water, what's going to happen to those wood chips? Those wood chips are going to come up here to the top, right? The wood's going to come up here to the top. The wood's going to float up to the top. The sand, right? The sand's all going to go to the bottom. Okay, the sand's all going to go to the bottom. Okay, and then the sugar is going to be dissolved. Okay, it's going to be like sugar plus H2O over here. We're going to have like sugar water. So kind of almost like Kool-Aid without dye. They're just going to be sitting in there. All right. So then I can just scoop. I can just we'll just say we're gonna remove. I don't know what I'm writing there. We're gonna remove. Okay. Goodness gracious. We're gonna remove the wood. So the wood's gone. We can just scrape the wood right out. We've removed the wood, and the wood is gone. Okay. So now I'm left with just sugar water and sand. I'm left with just sugar water and sand. So how can I get so the wood's gone. So how can I get rid of the sugar water and the sand? How could I separate those? Well, good. Yeah, I could filter. Okay, I could filter. That sand is just like coffee grounds, right? I could filter. Filter. And if I filter that, then I've removed the sand. Okay, so now I've removed the sand. The sand is now gone. Okay, because I can throw that out. Okay, we've removed the sand. The sand, she gone. Okay, sand is now gone. So now I just have a big old bucket of sugar water. Okay, I got a big old bucket of sugar water. How am I going to get the sugar out of the H2O? I hear some people saying distillation. I can hear you all the way from here. Okay, we're going to distill it. Okay, we're going to distill it. We're going to use distillations. We're going to distill it. Okay, which is again just a fancy word for boiling. And when we do that, we're going to be left with just the sugar very hard to write, and H2O. We're literally going to have a bucket of sugar and we're going to have a bucket of H2O. And that's how we would separate that big old mess right there. Again, this is something that we'll talk about in class when you're in class, because we're starting the more getting you back in the classroom, hopefully. If you have questions, make sure you reach out, and we'll be happy to answer for you. Hope this made sense. Have a great day.